Thank you, viewers. This is Mr. Odingo, and I want us today to continue with the equations of circles that we started last time. And please, before I begin, I would want you to subscribe to our channel, share, and also watch so that you can also support us in this particular program. Now, just straight to what we did last time. In the previous lesson, we were able to talk about how to calculate the equation of a circle. Now, today we want to now to relate equations of circles with straight lines. Sometimes, as you know, straight lines may intersect a circle, and we have drawn an example here where we could have a line, for example, line A here, which is intersecting this circle at a point. And in case point X here, at the point where the line A intersects the line, you realize at that point, point X, the line A is tangent to this particular circle, and therefore it means that we are only going to find, if you are supposed to calculate the point of intersection between line A and this cycle, you are only going to find the coordinate of one point. Now, if you come to point B, line B is intersecting the cycle at two particular points, Y, Z. So we can have, when we have this particular point like this, and you don't realize that when it divides this circle this way, we end up having what we call segment. We have this particular segment and this one segment. This line YZ becomes a chord. Now, when you come to this line C is actually not intersecting this particular circle at any given point. So it means that we have particular three scenarios that we can have: a line that do not intersect a circle, a line that intersects a circle at one point X. In our case here, this line therefore becomes the tangent to this particular circle, and then a line that divides a circle into two segments, the minor segment and the major segment, where line YZ in this particular case becomes a chord to this particular circle. Now, in this case, we are going to, because we are dealing with the coordinate geometry, we are going to look at the coordinates at which a line intersects a circle. That's what we are going to look at, and also be able to show that a line can intersect a circle or a line is not intersecting a circle. And for that, I want us to be able to move to an example and then see from our example what we are going to get. And the first example in our case, the first example will be, in this case, the first example, we have examples 1, we have find the coordinates, find the coordinates of the points, find the coordinates of the points where the line y equals to x plus 5 meets the circle, x squared plus y minus 2 squared equals to 29. So viewers, this is an equation here. We want to find the coordinates of the points where the line intersects, the line y equals to x plus 5 meets the circle with equation x squared plus y minus 2 in brackets squared equals to 29. Remember that this equation of a circle, like we have seen before, and this one here, you can see if this x here has no part of x squared has no part of other x, then it means that this one here, x is 0, while this one is x. The equation is for the y coordinate of the center is 2. But we are not going to deal with that particular point here. So you have these equations here, y x squared plus y minus 2 squared equals to 29. And we have another equation, y equals to x plus 5. If you have two equations like this and you want to be able to determine where the points where this line intersects the circle, then we are going to treat these two equations as simultaneous equations. So if we are going to treat this one as simultaneous equations, it means therefore that one thing I can first of all do here is to substitute where y is, I substitute x plus 5 in the equation 1, because I treat this one as equation 1 and this one here is equation 2. So the first thing I'll do is to be able, where y is here, because I have y already is made the subject of the equation in this particular subject of the in the second equation. I'll take x plus 5 and substitute where y is. So that will give me x squared plus, in bracket, y here is x plus 5, then minus 2. Everything here squared equals to 29. Viewers, what I'm trying to do is to solve an equation, to find the value of x and y. And for me to do that, I want to be able, we have many methods of solving simultaneous equations, but in this case, because we have probably a quadratic equation, we just have to depend on substitution method. And in this case, if I do that, we'll get x squared plus, this is x plus 3. X plus 3 squared will give me 29. Now, if we open this bracket, you can use quadratic identity. So that will be, this will be x squared plus 6x, because it's 2 times x times 3, then plus 3 squared is 9, equals to 29. So if I add this one, I'll get 2x squared plus 6x. If I bring 29 here, I will have minus 20 equals 0. So let me divide by 2, try to simplify, divide by 2, x squared plus 3x minus 10 equals to 0. Now viewers, I want to bring your attention to something before I move on. Now in your knowledge or concept of quadratic equations, probably in Form 3 or at AS level of A level, you realize that we can be able to determine whether this equation is going to give us 2 points or is not going to give us any point at all, or is going to give us 1 point by looking at what we call the discriminant of a quadratic equation. This is the discriminant of a quadratic equation. We said that if this discriminant is more than 0, then we are going to have 2 coordinates. It means that the equation, this line is intersecting this equation at 2 particular points. But if you have b squared minus 4ac, which I've said is the discriminant equal to 0, then we are going to have the line y equals to x plus 5 intersecting this line of the equation here of the circle at only 1 point. But if we find the discriminant of this equation 4ac is less than 0, then that means that this line y equals to x plus 5 does not intersect the equation, the circle with the equation x squared plus y minus 2 squared equals 29. Now let's try to find out what the discriminant will be. In this case, we'll say b squared is 3 squared minus 4 times a, which is 1, times c, which is negative 10. So we're going to have 3 squared, which is 9 here, 9 plus, because negative 4 times negative 10, that is 40 plus 40. So what we are going to have is that b squared here minus 4ac, according to this equation, is 40. This one is 49, sorry. So 49, it means that we have this one greater than z. So if it is greater than 0 like that, we are going to expect 2 values here. It means that this line y equals to x plus 5 is intersecting the circle with this equation at 2 different coordinates. So let us see. 2 numbers that if we multiply, we get negative 10, and if we add, we get 3. Which numbers are those? So we have 5 and 2. So if that 5 and 2, it means that they are, this one is, the bigger one is negative, the bigger one is positive, the smaller one is negative, yes. So if we add this one, we get 3, if we multiply, we get 10. So we are going to have x squared plus 5x minus 2x minus 10 equals to 0. If you group these two, we are going to have x into x plus 5 minus 2 into x plus 5, we get 0. So this one is x minus 2 into x plus 5 equals to 0. So we are going to have x equals to 2 or x equals to negative 5. So viewers, we have got the values of x, we should get the values of y. And for us to get the values of y, I'll bring this equation here. And bringing that equation will mean that, let me remove this. I hope you have understood what this one is was helping us with. It's not part of the working, but it's just helping us. Now, if I have to get y, and I know y equals to x plus 5, then it means that if x is 2, then y will be 7. And what about if x is negative 5? Y will be 5, negative 5 plus 5, and y will probably be 0. So what we are going to have here is the coordinates. Now we can say when x is 2, y is 7. So the first coordinate is 2, 7, and the other coordinate is when x is negative 5, y is 0. So we're going to have negative 5, 0. Viewers, these are the coordinates of the points where the line y equals to x plus 5 intersects the equation, the circle with this particular equation here. So that is very important for us to be able to note, and you can see that it's basically very easy to do. Let's move to example 2. Let's see example 2. And example 2 here is also very easy. Number 2, show that y equals to x minus 7 does not meet the circle, x plus 2 squared plus y squared equals to 33. So viewers, this is basically very simpler than what we have done in the first example. We are supposed to determine that what we have here, the line y equals to x minus 7 does not meet the equation, the circle with this equation. And like what I said before, how do we determine that? We have to also rely on what we call the discriminant of the quadratic equation, or the discriminant of that equation. If we said that if the discriminant is b squared minus 4ac, if it is the value of that figure there is going to be less than 0, then it does not meet. But if it is equal to 0, then it meets at one particular point. If it is greater than 0, then it means it's cutting that circle at two different points. Now, what do we do first? We first of all have to get the equation, the quadratic equation that we can solve in one unknown. So what I'm going to do, if you have y equals to x minus 7, and then x squared plus 2, x plus 2 squared plus y equals to y squared equals to 33, then what I'm going to do, I'm going to substitute what I did before. I want to solve this simultaneous equation, so what I'm going to do is to substitute value of y, which is x minus 7, where y is. So I'll have x plus 2 squared plus x minus 7 squared equals to 33. What I'm doing here in this case is to ensure that I cannot solve a quadratic equation in two unknowns, x and y. So I'm going to substitute from equation 1. I substitute equation 1 in equation 2, where I take all this value here and I put where y is. I will get something like this. So what I'm going to use quadratic identity to expand. This will be x squared plus 2 times x times 2, that is 4x, plus 4. 2 squared is 4. Then plus, this one here is x squared minus 2 times x times 7 is negative 14x plus 7 squared is 49. That one should give me 33. What I'm going to do, collect like terms, that is 2x squared minus 4x minus 14x. I'll get negative 10 x. Then I've dealt with this, I've dealt with that, I've dealt with this, I've dealt with that. Then I have 4 and 49. So I will have plus, I will have 4 here plus 49 minus 33 equals to 0. So I will have 2x squared minus 10x. So if I have 4 plus 49 here, I will get 4 plus 49, I get 53. 53 minus 33 is 20, plus 20 equals to 0. So this equation that I have here, as usual, I can be able to simplify, but that's not necessary. You can go ahead without simplifying. But if I simplify, I'll get x squared minus 5 x plus 10 equals to 0. Now, after reaching here, we are almost done. The only thing we need to do from here is to bring in the discriminant of this equation. And the discriminant here is b squared minus 4ac. And we have to substitute here where b is negative 5 squared minus 4 times a, which is 1, times c, which is 10. What I'm going to get, this is 25 minus 40. That is 40. And 25 minus 40 is negative 15. You realize the discriminant of this equation is negative 15. And I said that if the discriminant is less than 0, then it means that this line y equals x minus 7 doesn't intersect or doesn't meet that equation. It means that we don't have real values because we cannot be able to get the square root of negative 15. So what we are going to say, because b squared minus 4ac is less than 0, it means that the line y equals to x minus 7 does not meet the circle, x plus 2 squared, then plus y squared equals to 33. Viewers, that is basically very easy to determine. Let us look at another example. Example 3, which will be our last example in this particular case, to see how we should handle more questions. And the example here that we are going to have is example 3. Example 3a is saying, show that the line x plus y equals to 11 meets the circle with the equation x squared plus y minus 3 squared equals to 32 at only one point. Now, viewers, we have been told to be able to determine that the line x plus y equals to 11 meets the circle with equation x plus y minus 3 squared equals to 32 at only one point. Part B of this equation is asking us to find the coordinates. Find the coordinates of the point. Find the coordinates of the point. Find the coordinate of the point of intersection. So viewers, that is the equation that is before us. Show that the line x plus y equals to 11 meets the circle with the equation x plus y minus 3 squared equals 32 at only one point. Find the coordinates of the point of intersection. Now, what we have to handle in this particular case is, first of all, to deal with equation A. For us to deal with equation A, like we said before, we are going to have two equations, which is x plus y equals to 11, and the other equation is x squared plus y minus 3 squared equals to 32. And what we are asked in this particular case is to show that, so what we have to deal with this case is to show that actually this line x plus y equals to 11 intersects the circle with the equation x squared plus y minus 3 squared equals to 32. So we said that for us to determine that, first we have to really express this equation in form of a quadratic equation by actually dealing with one unknown. To deal with one unknown first, I want to bring this equation 1. I will call this one equation 1 and this one here equation 2. And if I do that, if I make y the subject in equation 1, then I will say y will be equals to 11 minus x. What I've just done is to take x to the side of the equation so that I have y equals, now I have the equivalent of y here, and what I have to substitute is to take this value of y and put it where y is. So I'll have x squared plus, in bracket, where y is 11 minus x, then minus 3. This 11 minus x is the one for y. This is the corresponding value of y, then minus 3 there. This one, all of it squared, equals to 32. So what I'll have here is x squared plus, this is 3 minus 11 should be 8. So we'll have 8 minus x there squared equals to 32. Now after have that one, what I do is to expand, open the bracket, and I'll use quadratic identity. 8 squared is 64 minus 2 times 8 is 16. 16 times x is 16x plus x, negative x squared is x squared equals to 32. What I do here, collect like terms. X squared plus x squared is 2x squared minus 16x plus 64 equals to 32. Now what I have to do in this particular case is to bring 32 here. So I'll have 2x squared minus 16x plus 32 minus 64 will be 32 equals to 0. Like I said before, I can simplify by dividing by 2. Divided by 2, I'll get x squared minus 8x plus 16 equals to 0. Now, after we have this equation, I said for us to show that it's meeting the graph or the circle, this line here is meeting this circle at only one point, and I said that point should actually be at the tangent. We need to go to the discriminant of the equation, the quadratic equation, which is actually b squared minus 4ac. Now, in this particular case here, b is negative 8, so negative 8 squared minus 4 times a, and a in this case is 1, which is here, times, and c here is 16. So what we are going to have, negative 8 squared is 64. 64 minus 4 times 16 is actually 64. So 64 minus 64 will be 0. You realize that the discriminant b squared minus 4ac is actually 0. And I said if the discriminant of the quadratic equation is equal to 0, it means that this line here is intersecting the circle with this equation here at only one particular point. Now we are finished with that. So we are going to say that x plus y equals to 11 meets the circle, and the circle here is x squared plus y minus 3 squared equals to 32 at one point, because b squared minus 4ac equals to 0. We have finished that. What about part B of the equation? Part B of the equation is asking us now to go ahead and find the coordinates of this particular equation. Now, if you realize that in this particular case here, we have equation x squared minus 8x plus 16 equals to 0. The two numbers that we've multiplied we get 16. If we add, we get negative 8. Will actually be negative 4 and negative 4. So what I'm going to do here in this particular case is to say x squared minus 4x minus 4x plus 16 equals to 0. This is group these two, group those two. X into x minus 4 into x minus 4 equals to 0. So in this case, x minus 4 into x minus 4 equals to 0. And what we can say in this particular case is that x equals to 4. If x equals to 4, and we know that y is there, y is actually equals to 11 minus x. So we are going to say y equals to 11 minus 4, which actually is 7. So you can say the coordinate here is 4, 7. This is the coordinate of the point where the line x plus y equals to 11 intersect the circle with the equation x squared plus y minus 3 squared equals to 32. So let's move to another aspect of equations of a cycle. Now the next part that we are dealing with is tangent and chord properties, and you realize that mathematics is very interesting because the concepts you have to deal with now here are actually concepts that you have met somewhere in the course of your study. For example, if you're looking at this first concept here about the tangent to a circle, the relationship between radius of a circle and the tangent to the circle, you realize that when you did what we call angle property circle theorem, in circle theorems, you were able to really understand that particular concept, that the radius of a circle is actually perpendicular to the tangent of that circle at the point where the radius and that circle are actually meeting. And that's what we have stated here, that a tangent to a circle is perpendicular to the radius of a circle at a point of intersection. So it means the angle between this one and this one here is actually 90 degrees. And we are going to see how this can be applied in actually coordinate geometry, when actually we are relating straight lines and equations of circles. Now when you come to the second idea we have to talk about here, that if you have a chord, we said that a line can intersect a circle at 2 points or at 1 point. This is the line which is forming a tangent here, is meeting the circle at 1 point. But there's also another line AB, which is, we are now calling it a chord, is intersecting the circle at 2 particular points. Now that line AB, which is a chord here, if you bisect it, you perpendicular bisect it, meaning you divide it into 2 equal parts, a straight line passing through the center, you going to realize that that bisector, which is actually this line here, will be a straight line that will be passing through the center of that particular circle. That is something that we are supposed to appreciate. And we are going to use that concept to be able to analyze in terms of circle or what we call coordinate geometry. Now, since we have understood the relationship between the bisector of a chord and the radius, it's now very easy to understand that if we have a chord here, then we draw a perpendicular bisector. That bisector must divide this circle into 2 equal parts, that half and this half here. It means that this perpendicular bisector here will be able to pass through the center of the circle, and as well will divide the chord into 2 equal parts. That's why you see this marks here. It indicates that the perpendicular bisector here is dividing this chord into 2 equal parts, and as such also dividing the circle into 2 equal parts. There's one half here and the other half on the other side. I want us to look at some example that we are going to use to apply these two concepts to be able to appreciate how they can be used in examples. So let's look at example 1. Now we have an equation here, which is our first example, and we are looking at a equation saying the circle C has equation x minus 2 squared plus y minus 6 squared equals to 100. I want you to understand that this equation is kind of already simplified for you so that you can be able to actually identify the center, the coordinate of the center of the circle. But sometimes the equation will be in the forms that we have seen before, where you have to derive this one by yourself. But because we have done that before, I want us to start from there to be able to illustrate what I want to explain here. Now we are told that the circle C has equation x minus 2 squared plus y minus 6 squared equals to 100. Verify that the point 10, 0 lies on C, meaning we are supposed to confirm or show that the coordinate P, which is 10, 0, is actually on the circumference of the circle. And for us to be able to determine that, we know that the distance between P and the center is actually the radius of that particular circle. And that radius should be able to give us 100. So if you do this and this, meaning where x, P is 10, mean x is 10 and y is 0, if we can be able to express that and get 100, then it means that this actually thing proves that point P is on the circle. But if we cannot get 100 by substituting 10 and 0 where x and y are, then that is not true. So the first thing we have to determine in this particular case is, if I have, let me solve A, if I have to get the distances, and the distances here between P and the center. So The center in this particular case, I can say the center here is 2, 6. That is the center, coordinate of the center. But we also know that we have coordinate P, which we have been told could be lying on the circumference of the circle. So if we want to do this particular thing here, what we know we do is to be able to get the distance between center, which is here, and P. This is the center and P. This distance here, it should be radius, which should be the square root of 100. Now, sometimes what I'm trying to tell you to use the radius format to go there is actually a long shot. It's long, but still will give the right answer. What I want to actually do is, I know that this is the center, and this is x, which is 10 here. Because remember when we are deriving the equation of a circle, we said if the point x, y is here, and this is the center, we derive what we call right angle triangle, where we get the distance here, which is actually going to be the center minus x, and that one minus y, we get the distance we calculate. So basically what I want just to assume that in this case we have x and y, which are actually the circumference. So what I'm going to do, that function I'll get 10 minus 2, because I know the equation is x minus 2 squared plus y minus 6 squared equals to 100. So what I want to ensure that x is here. We remember that 2 is what we have here, 6 is what we have, those are centers. Then 0 is actually here. So what I'm going to say is 10 minus 2 squared plus 0 minus 6 squared equals to what? What we are going to do in this particular case here is 8 squared plus negative 6 squared. So 8 squared is 64 plus negative 6 squared is 36, which actually this one will give us 100. So it's actually, this one can confirm to us that actually 10, 0, actually point P lies on the circumference of the equation, the circle with the equation x minus 2 squared plus y minus 6 squared. That is what we have there. Then they are telling us to find the equation of the tangent to C. I want you to know that the tangent, if this is the circle, we have determined maybe point P. At point this one, point P, so we can say P here is 10, 0. The tangent is passing there, touching the circle at one point only. It means that if I can actually be able to get this one, I have to get the gradient of this equation, the radius, the gradient of the radius itself here, where I know the radius here is 2, 6. If I can get the gradient of this one, then I know that the tangent, like we have said in the concept before, the tangent meets the radius at 90 degrees. It means that the tangent and the radius are perpendicular to each other. So we know the relation between perpendicular lines. The product of the gradient of this line, the radius, times the gradient of the tangent, I should get negative 1. But let's first of all get the tangent of line that is passing through the center and point P. And that gradient there, if I'm looking at answer B, the gradient will be, we know that change in y, m equals to change, let me call it m1, change in y over change in x. I'm getting the gradient of the line passing through the center and point P, which is 10, 0. So I'm going to get, let me take this one, x1, y1, x2, y2. So what I'm going to have is, this is y1 minus y2 minus y1 over x2 minus x1. So what I'm going to have here is m1, which is the first gradient I'm getting, is 0 minus, that's y2, y1 is 6, minus 6 over x2 is 10 minus x1 is 2. So m1 here will be negative 6 over 8, which actually will be negative 3 over 4. So we have the gradient of the line, which is actually the radius. But we know that that radius is meeting the tangent at 90 degrees. So what about the gradient of the tangent, which is m2? For us to get this one, we know that m1, if they are perpendicular, times m2 should be negative 1. So if we relate this one, our m1 already we have negative 3 over 4 times m2, which is the gradient of the tangent, is negative 1, m2 here will be negative 1 times the reciprocal of this one is negative 4 over 3, which will say m2 in this particular case, negative times negative positive, will be 4 over 3. So we have the gradient of the tangent, and we know that that tangent is also passing through the point 10, 0. So we know we have m, which is 4 over 3. We have a coordinate 10, 0. We can choose another arbitrary coordinate x, y. So we'll say y minus 0 over x minus 10 equals to 4 over 3. If I multiply this one, I'll say 3y equals to, because 0 is 0, equals to 4x minus 40. So if we write the equation, we are told to write the equation in the form of ax plus by plus c equals to 0. This is, I will take y the other side, so I'll say 4x minus 3y minus 40 equals to 0. This will be the equation of the tangent to C at the point 10, 0 to the circle. So this is the equation. We remember that we have seen many ways to write this equation. We can write it in this form: ax plus by plus c equals 0, ax plus by equals to c, y equals to mx plus c. Those are ways of writing this particular equation. Now viewers, we have example 2 here, which says a circle has equation x minus 5 squared plus y plus 3 squared equals to 10. The line L is a tangent to the circle and has the gradient negative 3. Find two possible equations for L, giving you answer in the form y equals to mx plus c. Now these questions appear easy, but I think it requires a lot of thinking, and I want us to go through it slowly by slowly to see how we need to think. Now from this equation first, we can be able to sketch. If I have this as my circle, and from this circle it has the equation, there's one here. And the other thing we need to be able to know, forgive my drawing. Now we know that this circle has got a tangent, and we have also seen the relation between a tangent of a circle and a radius. And the radius, if I draw this as the radius and this as the tangent here, we know that we have been told that the gradient of the circle here as the gradient m equals to negative 3. So what about the gradient of this other one here? The gradient, we know how we are going to get them. The product of the gradient of this one times the gradient of that one should give us negative 1. But we have asked to give two possible equations, meaning two possible tangents. We now have a tangent here, but we can have this a tangent on the opposite side, because if I sketch it this way, another person could sketch it this way. So that's what's going to give us two possible equation. You see where we have now the equation of two possible values. So we are going to have two tangents here, and we know that this tangent and this tangent, they are parallel to each other. So if they are parallel to each other, the equation here, or the gradient of these two tangents, are the same, because they are parallel to each other. Another thing we are supposed to appreciate in this particular case is that from this equation here, we can be able to locate that the center of this circle is actually 5, negative 3. We have seen how to get the center from equation of a circle before. So what do we do from here? What do we actually do from here? The first thing, we cannot get equation of this particular tangents without getting the point where they meet the circle. That is very important. And how do we get those particular points? We really have to get the equation of this line that is actually passing through the radius, this one here. If we can get the equation of this line, then it means we can be able to use that equation with the equation of the circle to get where that line is actually intersecting the circle, which we have also learned before. So here, what do we do at this particular point? What I do in this particular point, I'm going to be able to get the gradient of this line, the center, or the line, the chord. This chord here is dividing the circle into two parts. And how do I get its gradient? The gradient of the tangent is here, negative 3. And I know that the gradient of this tangent times the gradient of this chord will give me -1. So that's where I begin. Let me take the gradient of the tangent to be M1 and the gradient of the chord, let me say chord is AB. So the gradient of chord AB is M2 and the gradient of the tangent, and the tangent I can have the tangent X or tangent Y. Tangent, let me say this is capital X, or let me say P, because we have XY in the equation, we may get confused. So tangent P and tangent Q, so tangent P and Q, their gradients are the same because they are parallel to each other. And that one you have understood. M2 is actually perpendicular to the tangent. So the product will give me -1. But luckily, we are given the gradient of the tangent to the circle, which is -3 times M2 will give me -1. So it means that if I divide by -3, divide by -3, the gradient of the chord will be +1/3. Now I have the gradient of the chord, this chord here, which is 1/3. Now if I have that gradient, but I have one of the coordinates where that chord is passing, I can get this equation. And how do I do that? I now have the gradient here, which is 1/3, another coordinate 5, -3, and x, y. This one will help me to go through y plus 3 divided by x minus 5 will give me 1/3, which means I will have 3y plus 9 equals to x minus 5. That means 3y equals to x minus 5 minus 9. This is 3y equals to x minus 14 over 3 over 3 over 3. So I'll get y equals to 1/3 x minus 14 over 3. Now we have got, this is the equation, and if we can go through once again, we have said this is the gradient of the chord, and the chord passes through the center, which is 5, -3. So getting that, I'll say y minus y1 minus y2, which is y minus 3, that's y plus 3, x minus 5 equals to 1/3. We cross multiply, this times this 3y, this time this is 9, that times 1 is just x minus 5. Then taking that one the other side, we have 3y equals to x minus 5 minus 9, which is minus 14. And then finally, this is the equation of this chord. Now, we have to go to the most critical part, which is actually now determining the coordinate of this point and the coordinate of that point. And we know that the coordinate of this point and the coordinate of that point will be obtained when we actually relate this equation. This is the chord. We know how to determine how the coordinates of the points where a straight line is intersecting a circle. The equation of the circle is here, which is x minus 5 squared plus y plus 3 squared equals to 10. So, and we have another equation which is passing through that particular one, which is 1/3 x minus 14 over 3. Now, we have now these equations. The first equation here is the equation of the circle, and this equation is the equation of the chord, which is intersecting the circle at point A and B. The two coordinates, the 2 points here, A and B on the other side. So what we are aiming is to get the coordinate of this A and the coordinate of B, and for us to do that, these two lines will now serve as simultaneous equations. Now, for us to handle simultaneous equations, we really have to use substitution in this case. So I'm going to substitute the value of y here, which is 1/3 x minus 14 over 3, where y is in this particular equation of the circle here. So I'll do x minus 5 squared plus, where y is, I take 1/3 x minus 14 over 3 plus 3. Then squared equals to 10. What I've simply done is to take this part here, which is here for y, because this is y, then plus 3, which is added to y the other side. So what we are going to do here is x minus 5 squared plus 1/3 x, let's do negative 14 over 3 plus 3. The answer is negative 5 over 3 squared equals to 10. So if we open this one using quadratic identity, we are going to have x squared minus 10x plus 5. What did I do? I square x, then the next one I take 2 times x times negative 5, which is negative 10. Then 5 squared here should actually be 25, sorry. 25 plus, then we square third x, which is 1 over 9 x squared minus 2 times a third is 2 thirds. Let us do that. 2 times a third, then times. So 2 times a third is 2 thirds times negative 5 over 3 times negative 5 over 3. We get negative 10 over 9x. Then plus this one squared, negative 5 over 3 squared will be actually 25 over 9 equals to 10. Now moving forward, we collect like terms. So this one is x squared plus 1 over 9x is 1 and 1 over 9x. In proper fraction it becomes 10 over 9x squared. Minus, we have 10, let's do that, negative 10 minus 10 over 9 is actually 100 over 9x. Then let us have 25 plus 25 over 9, 25 plus 25 over 9. We actually get plus 250 over 9 equals to 10. Now doing this one, I said we can now be able to remove the fraction by multiplying by 9 everything. So we open bracket using 9, we get 10x squared minus 100x plus 250 equals to 90. If we be able to bring 90 here, we'll get 10x squared minus 100x plus 250 minus 90. We get 160 equals to 0. Let us divide everything by 10. By 10, by 10, by 10. We get x squared minus 10x plus 16 equals to 0. So viewers, we have an equation here which has got, we have simplified it. Now after simplifying this particular equation here, we can then be able to do what? We can be able to find the two numbers that we multiply. We can get a product which is 2 and 8. So negative 2, negative 8, which are the numbers. So we have x squared minus 2x minus 8x plus 16 equals to 0. Group these two. I will have x into x minus 2 minus 8 into x minus 2 equals to 0. In this case, x minus 8 into x minus 2 equals to 0. So x equals to 8 or x equals to 2. We have found the values of x. The next thing, we have to get the values of y so that we can be able to determine the coordinate, the full coordinates of this particular points. The coordinate here, y, we have said equals to here. Let's come here, equals to a third x minus 14 over 3. So what we are supposed to do here is to substitute 8 for x. I'll have y equals to a third into 8 minus 14 over 3. Let me do that. I'll have 8 over 3 minus 14 over 3. What I'll get here is negative 2. Negative 2. So viewers, we have to create some space so that we can be able to handle this issue as appropriate. So we can use now, for the first coordinate, if x is 8, y is negative 2. As we have said here, y is negative 2. Let me use the other side to find it. Another one, when x is 2, so I'll say y equals to a third x, where x is 2, then minus 14 over 3. y will be, what I'm going to do get there is 2 over 3 minus 14 over 3. What I get there is negative 4. So another coordinate is that if we have x for 2, y is negative 4. So we have coordinates now. The first coordinate is 8, negative 2, 2, negative 4. So 8, negative 2, and 2, negative 4. These are the coordinates of the 2 points where the chord is intersecting the circle. If I sketch it here, I told you we had something like this. Then we have the chord here. So this point here and that point there is what we got here. So now that we have this chord, we have got the points which is passing through this line, and another point which is passing through that line. So we know that the gradient of these tangents were negative 3, and since they are parallel, both of them have a gradient of negative 3, and we have a coordinate for 1 and another coordinate for 1. So we can actually use these ones to get the equations of the 2 possible equations for L, which is going to be the first one. I'm using this coordinate with the gradient negative 3, and the other one I'm using this coordinate with the gradient negative 3. So the first one I'll say y plus 2 over x minus 8, I will get negative 3 over 1. This will be y plus 2 equals to, this times this is negative 3x plus 24. So what I'll do here, y equals to negative 3x plus 22, because what I'll do is to subtract this one the other side. And if I subtract, this is equation 1 of L. The other equation 1, the equation 2 of L will be y plus 4 over x minus 2 equals to negative 3 over 1. This time this is y plus 4 equals to negative 3x plus 6. So y equals to 3x, negative 3x plus 6 minus 4. This is y equals to negative 3x plus 2. So viewers, we have 2 equations that we have got here, and the 2 equations, possible equations of L, are y equals to negative 3x plus 22. Another one is y equals to negative 3 plus 2x. After determining these equations, we have finished the equation. That is what the equation wanted. And let me go through back what we did before. We said that the sketch I did was this, the circle with the equation here. These are the possible tangents, because they wanted 2 possible tangents. If a tangent is on one side of the circle, it can also be on the opposite side of the circle, in which case the gradients of these tangents are equal because those tangents are parallel. Then what we did, we used this equation of the circle to get the center of the circle, and through that center of the circle, we are able to determine the equation of the radius, equation of the radius, which is actually the equation of the chord, or the equation of the diameter. And that equation, we worked it out here, being that we know that this radius will meet the tangent at 90 degrees. So the product of this gradient and times the gradient of that particular line will give us negative 1. And the gradient of the tangent was negative 3. So the gradient of the radius will be, we work out m1 times m2 is equal to negative 1. If the tangent is m1, which is negative 3, then we get the gradient of the radius as a third. From getting to a third, the center of the circle is 5, negative 3. We substituted to get the equation of the radius, or the equation of the chord, or the equation of the diameter. All those can be working there. So we want to know how does this chord here intersect the equation, this one. So therefore we use substitution, where we took this part, we put in y, and then we expand to get what we call a quadratic equation. Then from there we got 2 coordinates. The 2 coordinates on the circumference, where the chord is actually intersecting the circle. After getting those coordinates, we know that the gradient of these tangents are actually negative 3. And those coordinates are also on the tangent, so we were able to get the gradient of the tangents, which actually are the 2 equations of what we call line L, because line L actually are the cotangents that we have there. Now viewers, we want to look at the last question under this particular area. And the question says the point P and Q lie on a circle with the center C as shown in the diagram, and the diagram is here. You can see point P and point Q. As shown in the diagram, the point P as coordinates negative 7, negative 1, and the point Q as coordinate 3, negative 5. 3, negative 5. M is the midpoint of PQ. The line L passes through point M and C. This is the line L. Find the equation for L given the y coordinate is negative 8. The y coordinate of C, so the y coordinate of C here, the coordinate of y is actually negative 8. Now what we have to do in this particular case first is to determine the midpoint M. Now the midpoint M is point A. The midpoint M, we know M should be x1 plus x2 over 2, y1 plus y2 over 2. Now M in this particular case, x1, if this is Q, let me say Q here is 3, negative 5, and P here is negative 7, negative 1. So what we are supposed to do is x1 is negative 7 plus x2, 3 over 2. Then y1 is negative 1 plus y2 is negative 5. Let me say negative 5 here over 2. What you're supposed to get here is that negative 7 plus 3 is 4. 4 over 2 is 2. Negative 7, so negative 7 plus 3 should be negative 4. Negative 4 over 2 should be negative 2. Then negative 1, negative 5 should give us negative 6 over 2 is negative 3. So this is the coordinate of the point M, which is the center here. Now what we know here is that if you have this coordinate here, let me say this is the coordinate of the point. We know that this here we can get the gradient of this line PQ. The gradient of line PQ, let me say, is y1. M is y1 minus y2, or y2 minus y1 over x2 minus x1. That will be, let me take this one as y, the y, x2, y2, x1, y1. So y2 here is negative 5 minus x1 is negative 1 over, y1. So x2 is 3 minus x1 is negative 7. What we'll get here is 5 plus 1, which is negative 4, over 3 plus 7, which is actually 10. That will give us negative 2 over 5. So that gradient there is the gradient of this line. What about the gradient of this line, which is actually perpendicular to it, will be, let's say, M1, M2 is actually negative 1, and M1 is negative 2 over 5 times M2, negative 1. M2 here should actually be positive 5 over 2. So we have got the gradient of this equation. We have one of the coordinates where that equation is passing through. So let us find the equation first. The equation here, the equation will be y minus, the coordinate here is y plus 3 over x plus 2 should give us 5 over 2. This one will be 2y plus 6 equals to 5x plus 10. This will be 2y equals to 5x plus 10 minus 6. So 2y equals to 5x plus 4 over 2 over 2 over 2. Y should be 5 over 2x plus 2. We have got the equation of the line L. The equation of the line L, we need now to go to the equation of, show that the coordinate of the x coordinate of C is 4. The x coordinate of C is 4. Now we know that given that this question is here, given that y coordinate is this, show that this one is equal to this. So if we know that this question here is passing through the center, where we know y, we don't just substitute, this is b, we just substitute y here. So if for us to get 5 over 2x plus 2, for us to get the value of x, we have the value of y, where should be given that, given y coordinate is that, y coordinate is -8, show that, this is so. Let us show that that one is equal to that. Let's say y is equals to 8, -8 equals to 5 over 2x plus 2. Let me bring 2 here, which will be -10 equals to 5 over 2x. So for me to find x, I will say it is 2 over 5 times -10 times -10. What am I doing? I'm actually multiplying by reciprocal, times 5 over 2 times 5 over 2. So 5 here 1, here 2, x here equals to -4. So we have actually shown that the x coordinate of the center is actually -10. So the coordinate of the center of the circle, the coordinate of the center, if you go to point C, which is now asking us to be able to find the equation of the circle, we know that we have to get the center of the circle, which is actually -4, -8. That's what they told us. The C is the center, and the y coordinate is -8, and we have got the x coordinate with -4. So this is the center of the circle. But we know that there's either this coordinate or this coordinate on the circumference, because we have to get its radius. So what we are supposed to do here is the radius of the circle is actually the distances. Let me say the distance. If I talk about CQ, distance CQ here will actually be, when I subtract the two coordinates, and the coordinate of Q here is 3, -5. So if I subtract the coordinates, what I'll say that radius here will be the square root of x2 minus x1 squared plus y2 minus y1, everything squared. I hope you understand that from our previous lessons. This will be x1. Let me take this as x1, so -4 minus 3 squared plus -8 plus, because minus -5 will be plus 5 squared. So r here will be the square root of -4 minus 3 is 7. 7 squared is 49 plus -8 plus 5 is 3, -3 squared is 9. So r here will be sad 49 plus 9 is actually 58, sad 58. Now we have the sad of 58 as the radius. Now if we have the radius and we have the center, then we know that finding the equation will actually be very, very simple. How do we find the equation? We know that equation should have been x minus a squared plus bx plus y minus b squared is actually equal to radius squared. So let us find out that our x, in this case, it remains just x minus a, where a is the coordinate of the center, and the coordinate of the center is here, -4. So x minus -4 will be x plus 4 squared plus y minus, the other coordinate is -8, so y minus -8 is plus 8 squared, should give us radius, which is actually the surd of 58 squared. What we can do from here is x squared plus 8x plus 16 plus y squared plus 16x plus 64, this is y, sorry, will be equals to 58, because the surd of 58 squared is actually 58. So if I bring x squared plus y squared plus 8x plus 16y plus 64 minus that, you have 64 minus 58, 64 minus 58, you get 6. 6 equals to 0. Remember also that you could just have left the answer from here by simply saying x plus 4 squared plus y plus 8 squared equals to 58. There's no harm in doing that. But as we have seen before, you can also leave the answer in this particular form. Now viewers, you have seen how this lesson is actually involving a lot, where we actually now deal with circles and straight lines. And the concepts we have been using here are actually a collection of concepts gathered throughout the course of your study, from angle properties, that is circle theorem, coming to equation of straight lines, coming to quadratic equations, where we actually use discriminants to determine whether we are going to have 2 intersection points or 1 intersection point or none at all. Then we came also to quadratic equation to help us actually be able to solve a quadratic equation. Then finally we come to what we call the equation of a circle. All those concepts brought together will help you to actually deal with these particular issues. Now viewers, that is the end of our lesson today. If you loved our video, please share widely, watch it, and also subscribe to our channel so that you can also support us doing this work of teaching your students during this particular time.